When it comes to demand planning, there are a few different ways that demand planning can happen. Traditionally, demand planning would necessitate sending a lot of historical information, custom models would be built, or you'd have to use an out-of-the-box model that an organization has already built and fit your existing historical data into that model. And then the output would either be too generic, you'd have to wait months and months to get a model that fit, and it would be very difficult to iterate on that model, and you may not have data that's really tailored to your organizational needs. In WorkAxle, we've actually developed a really cool approach to this where you can upload any historical data for your organization. It could be as multivariate as needed. For example, in retail, you may have footfall, you may have transaction history, you may have sales history, you may have things like weather or nearby events that could affect the demand forecast. If you're in transportation, it could be the foot traffic within the airport, it could be the time between flights. Whatever metrics you have can be uploaded directly to our demand forecasting agent. That demand forecasting agent will go and test out different types of forecasting models to find the best fit, find the seasonal trends, find the appropriate residuals, and then leveraging that model, tailor it to the specific needs of your organization and the data that you have on hand, and then provide a proper demand forecast. That data then gets refed into the model to sharpen it to become more accurate over time. So to recap, you can take any data and it could be generalized, put into the system. The system will find the appropriate model that fits your organization's needs. It will tailor the output, and then what is generated from that model and used within the WorkAxle platform can then be refed into the model to have it be improved over time. And this is where the learning component on the model is so powerful, reinforcing the trends that may have been forecasted or penalizing or training the model to have it be more accurate in the case that it was off from its forecast. And over time, you end up coming down with something that's a lot more certain.